So this is a concluding video about the problem with rectangle that we're trying to divide into two similar but not congruent polygons. We're discussing why we cannot dissect a square in this way. So the first thing, even when you thought about rectangle, to divide it, you thought if these are two polygons, it means there should be a broken line dividing this picture into parts, right? And then this broken line has two endpoints. One of them we can say on this side, and the other one we don't know, right? Suppose it is here, right? But then you can have some broken line that goes this way, right? Can we have two polygons that are similar and connected, having a broken line connecting two points that are on two consecutive sides?
Well, if we look at the number of sides of the polygons,
Number of sides, right?
they will not be the same.
Or same, you can look at the number of vertices, right?
Yeah.
In this polygon, all these vertices belong to it plus 1. In this polygon, all vertices belong to it plus 3, right? So this is impossible.
But I want to stop you for 1 second. I think you're missing one critical sentence here in your writing. You do not have two such boundary points cuts like this.
Oh, so you mean like?
You are telling me this is the only one. Then I can say, okay, how many common points, and then add 3 and add 1. But what if I have two such things?
Two broken lines.
Two broken lines.
Wait, then you would not be able to cut it into two different polygons.
Exactly, that's what I need to say. So you do need to emphasize that.
Yes, yes, you're right.
Right? The two, you have one continuous what? Boundary. You cannot have two, because if you have two boundaries, you might have more pieces, or you have inner pieces right here. Right? Yeah.
And here we can be careful. This point also can be the vertex of the square.
Right.
But our argument with counting still works in the same way.
Right. Yeah.
So it's not 1, 3, it can be 1, 2 if we consider a vertex, for example.
Okay, so it has to be one side outside or one vertex to be opposite vertex.
Yes.
Yes, so we can say one of our vertex lies on this segment, including the corners
Yeah.
and points, and one of this lies somewhere there. So somehow,
And we including the endpoints.
Yeah. Yeah.
Right? Because like you said, it could be diagonal. Right?
so first point is here, the second point is somewhere here.
Yeah.
So now, why cannot we have these two polygons to be similar by not congruent, but not congruent?
I think the key here is the non-congruent, because clearly we can cut them into two pieces that are similar and congruent, basically congruent, right? If you use the midline, right? So non-congruent is a important thing, right? And they share the common sides.
So here the argument that we use is an extremal argument, right? We can take a look at the longest side.
Of the two polygons. Yeah.
So for this one, there are actually two options depending on our picture, right? I can have something like this here. My longest side of the top polygon will be either this line, which has side length 1.
Yes.
It cannot be this segments on the sides because their length is less than 1. And it can be maybe this line that both of these polygons share.
That would be at least one.
So if you look at the longest segment,
I think you might want to write those things now. What are you really looking at?
So call the two polygons P1 and P2. Okay. So you're claiming that the longest segment of P1 is equal to the longest segment of P2?
Longest segment of P1 says L1,
Right.
for example.
longest segment P2 is so our claim is that L1 is equal to L2. And the way we prove it, we say that the longest side, it's either this side length of the square that is equal to 1, or it's the side that they both share.
I think there's also one small case to be careful is like if the boundary line goes through two opposite vertices, then each of the two polygons will have two sides of length 1.
But that was
But that will still be the same thing. We just need to make sure that they correspond correctly.
No. I don't think this is what you should attack your proof. I do not think that his proof is very clean by spotting those points. I think that you should go directly with this. If your number side is more than 1, what happens?
And it has to be
If L1 is more than 1, what happens? It's much easier to go this way. If L1 is more than 1, it has to be inside.
So it means
And if it's inside, then it has to be equal to L2.
Yeah.
Because they share, right? Because this is a common side, right?
Yeah.
Right? If it's L1 is more than 1, then they share this. L2 cannot be something else. Because if they share, then that one will be the number 1. Right? If L1 is 1, then it's okay. Because in your picture, you have a what? 1 also. That's your number side.
Yeah.
It doesn't
and
matter if you have
It doesn't
two
matter. It doesn't matter, right?
And also there's nothing greater than 1 in the broken line there. So
Yeah.
yes.
Yeah. So you go for the position of this segment.
Then the key thing is to confirm that L1 and L2 need to correspond.
Right.
Yes, but the ratio of the similarity is the ratio of the longest side to the longest side.
If you have a multiple one, it's still the same.
Yeah.
Right?
But it's still something
yeah, but that's also equal to 2.
Yeah.
Right.
Which means the ratio of similarity is 1, which means they're another one.
Yeah. Right.